See, guys, let's see this property here. Here, this is a raised to power log b base c. So here the thing is, what happens is between a and b. So this property states that a and b are interchanged. The base remains same. So b will come here and a will come in the argument side like this. C will remain as it is. So here the base was c in the log, which was in the power of a. So here also it will remain to be at the same place. The only thing is the place of the positions of a and b are interchanged. So this is the next property. It should not be confused with x a to the power log x base a, where this and this a and here a both are same. In that case, the answer was x in the previous property that we have studied. So this is different, guys. Okay. So now what about ABC? So as you can see here, A is positive clearly. Okay. So A is positive. C is also positive, but not equal to 1. Okay. And B is also positive, because since C is in the base, so we cannot put C as 1. Okay. So that way it is defined. The constraints on A, B, C are like that. A is positive and B as well. C positive but not equal to 1. So for example, let's see the proof. The left hand side, a to the power log b base c. Log b base c I have written as log b upon log c. The question that I wanted to ask you guys, then what should be the base here? We are trying to prove this. So yes, guys, the base that we will take here is a. Okay. Now here we can write this term, this particular term, log c base a, as log 1 upon log. It will come in the numerator multiplication, where a and c would be interchanged using the property log 1 upon log m base n is log n base m. As you can see here, a and c are interchanged here. So log a base c, it became in the previous step it was log c base a. Okay. So now this log b base a, this term log b base a, it is same here as well. Okay. So what next? Now we will put this term, this entire term log a base c in the power of b using this rule m log n equals to log n to the power m, like this. It will come in the power of b. So log b to the power log a base c, it will become. So now as you can see, a here in the base, here also it is in the base. So the answer would be this thing only. This entire thing would be whatever is there in front of log, that will come as the answer. Why? Because we know we will use this a to the power log k base a is k. So we can say that this thing is, this log a base c is k. So okay, so this is equal to RHS. So that way it is proved, guys. Okay. So for example, 3 to the power log 17 base 5, we can write using this property. Will interchange what, guys? Yes, we will interchange 17 and 3. So 17 will come here and 3 will go in the argument side. Base 5 will remain as it is. In the similar way, if I ask you to write, use the property, so 12 to the power log 1 by 15, which is the argument and base is 4, can be rewritten as what? Yes, 1 by 15 will come to the power, it will come 12 as argument and base is as it is 4. Now, if suppose in a question, 3 to the power log x base 5 plus 5 times x to the power log 3 base 5 is 54 is given, we have to find x. How we can approach this, guys? So first of all, we can see here that if we observe here x and 3, if they are interchanged, we will get this term. Okay, it means this term, the first term, which is this, and the second term, which is in which 5 is multiplied, these two terms are same. Okay, so now this also, if it is taken in terms of 3 power of 3, because we will convert this to the power of 3, because this can be expressed in the power of 3. We will try to express 54 in the power of 3. Okay, 3 to the power something, we will try to express for 54 as a multiple of 3 to the power something. So if you see, 54 is nothing but 6 into 3 square. So that way we will proceed, guys. Okay, so the solution, the question, as you can see, as I said, the second term, this we will use the property 3 and x will be interchanged, so it becomes 3 to the power log x base 5. Other terms, first as it is 5 plus 5 multiplication as it is 54. So now this 3 to the power log x base 5 we will take common, so we are left with 1 here and 5 here. 54 we will write in the next step as 6 into 3 square. 5 plus 1 will be 6, and 6 cancels out both sides, so we are left with 3 to the power log x 3 to the power 2. So these two should be equal because the base is 3 is same. So in the next step, equating the powers, log x base 5 equals to 2. So x, using removing the log, using in logarithmic form, exponential form, you will get x as 25 square, which is 25, guys. Let's see this question, guys. This is 6 by 5 a to the power log x base a multiplied by log a base 10 log 5 base a. All these terms are in multiplication. Then the next term is minus 3 to the power log x base 10 is equal to 9 to the power log x base 100 plus log 2 base 4. We have to find the value of x. So how we can approach this? So as you can see here, there are 3 terms involved. This is first minus second term is equal to third term. This is third term, and this is first and this is second. So how we can find it, guys? Okay, so what should be the hint approach? So guys, the hint is we have to, as you can see, all the terms are containing a bit of complex terms. So initially we will simplify each term. Rather, we will simplify the power of each term. And when we simplify, we will use log of logarithms like log a base b log b base c is equal to log a base c, and a to the power log b base c is equal to b to the power log a base c, and so on. So we will simplify all the 3 terms and then we will substitute it in the question. So we will start with simplifying the first term, which is 6 by 5 a to the power log x base a into log a base 10 log a base 5. Now as you can see here, log a base 10 log 5 base a can be written as log 5 base 10 using the property, this term as it is. Okay, now this log 5 base 10 I have written here. So now this term will go in the power of log x base a using the property log m log n is log n to the power m. Log 5 base x goes in the power. So this was in multiplication, now it's in the power. Okay, rest other things are as now directly. Now this, if you see, you can directly use another law, a to the power log b base a is equal to b. So where b is this whole thing. Okay, so this we can write like this. Okay, so 6 by 5 as it is. Let's say this is what, this is equation, this is first term is simplified as 1. Simplifying the second term, which is this, so log m by n is log m minus log n, we will use log 10 base 10 is 1. This is as it is, 3 is as it is. So this is second, guys. That's it. Now we will simplify the third term, which is in given in RHS, 9 to the power log x base 100 plus log 2 base 4. So what we will do, we will factorize here and here, and this 2 will go down in division using log m base n to the power a, so 1 by a. So 1 by a here is 1 by 2 log m base n, so log x base 10. Similarly here also 2 square, so 2 will come down, okay, from the power of 2. This 2 in the argument is as it is here. So now this 2, which is in multiplication, is multiplied in both the terms, making them 1. So finally we got third as this. Now substituting first, second, third, which were the simplified values of first, second. This was the first term. The first term simplified is this. Now the second term is this simplified as, and the third term in the right hand side is simplified as this. Okay, guys. So now we will take this term, second term in right hand side, so it becomes plus. Okay, now we will do, as you can see in both the right hand side, both the terms having the same power and same base, that thing we can take common, 3 to the power log x base as common, so we are left with 3 to the power minus 1 and 3 to the power 1. Right hand side, left hand side is as it is. Now this 1 by 3 plus 3 gives 10 by 3. Now we will write left hand side, which was 6 by 5 x power 5 by 10, and this 6 gets cancelled with this 10. So we are left with 5 here and 3 here. Okay, so this term is as it is here. This 3 becomes 3 square. Why? Because this 3 is transferred here. So this becomes 3 square. Now here, as you can see, this is 3 to the power log x base 10 3 square. So this is 5 square. So what should come here? So similar to what is in the right hand side, what we can do, this question mark, we can apply the property 5 to the power log, this can be written as 5 log x base 10. This term can be written like this, using which property? Using the property a to the power log b base c, base and argument and base are interchanged, so b to the power log a base c. Okay, so using that, so as you can see here, now LHS is 5 to the power, same is 3 to the power log x base 10 minus 2, which is RHS. So taking 3 here in the denominator, since power is same, so we can write 5 by 3 whole to the power log x minus 2, which is 1. So 1 is equal to what, guys? So how to solve this? So you can use the definition of log, or you can write it in exponent as 5 by 3 to the power what? Yes, 0. So equating the powers, log x base 10 minus 2 is 0, which gives this, and x is 100, which is what? Which is the final answer, guys. Let's see how we define terms related to the log value. See, if the value of log x, it can be any value like log 10 base 10 is 1. It can be fraction, it can be whole number, it can be any real number. So it is expressed as sum of two numbers. One is c, another is m. C is called characteristic of log x base 10. Base 10 is called common logarithm. If the base of the logarithm is 10, it is called common logarithm. We are discussing for common logarithm only. M stands for mantissa. Okay, so what is c belongs to what and m belongs to what? So log x base 10, the value of log x base 10 can be expressed as c plus m. So what is c and what is m? So it's like this, guys. If log 0.005 base 10, if its value is minus 2.301, so it is expressed as minus 3 plus 0.699. So minus 3 is what we call the characteristic, m is positive fraction, which is called mantissa. Like here also, if it is log 0.8, if it is 10, base 10 is minus 1.096, then it is expressed in terms of Cn as a what? So we can write it like this, guys. Minus 1 plus 0.96, minus 1 minus 0.96, minus 2 plus 1 minus 0.96, which is minus 2 plus 0.904. So this is mantissa, which is a positive fraction. Minus 2, this is a integer, an integer. Why? Because for other values, like if you see log 5000 base 10, the value is 4.698. So it can be expressed as 4 plus 0.698. So the characteristic here is 4, mantissa is 0.698. So here also log 2 base 10, if it is 0.301, what is characteristic and what is the mantissa here? So yes, it is, the characteristic is 0 and mantissa is 0.301. So as you can see, it is taking the value of c, which is characteristic. It is taking any real value, and mantissa specifically it is taking 0 to 1. Mantissa can be 0 if it is like this. As you can see, log 10 base 10 mantissa is 0, characteristic is 1 here. Log 15 base 10, characteristic is 1, mantissa is 0.176. And we are discussing for common logarithm, which is log whose base is 10. There also exists a natural logarithm that we see mostly in calculus, where the base is e, and that is also written ln x. Log x base e can be written as ln x, natural logarithm. As of now, we are mainly concerned with common logarithm log x with the base 10, where the log tables are made. Okay, so why we are doing this, why we are defining the characteristic in mantissa here, where characteristic, as I said, belongs to set of integers and m is a positive fraction, it can be 0 also. It is used to find number of digits in a natural number n, where n is a big natural number. Why big? Because if it is a small natural number like this, and we need to find number of digits like where n is 1, 2, 3, 4 directly by looking at it, we can say that number of digits is 4. Here also we can simply count 1, 2, 3, 4, 5, 6, 7, and we can directly write the answer as 7. 2 to the power 10, a little bit we have to calculate, or if we remember the value, 2 to the power 5 into 2 to the power 5, which is 32 into 32 is 1024. 1024, so number of digits is 4. But what if the power increases? So as I said, it is mostly used for finding number of digits of n, where n is generally a big natural number, which is expressed in the form of a to the power b. Generally, n is expressed as a form of a to the power b like this. Example, n is 2 to the power 36 to the power 52, etc. Here finding number of digits. Number of digits is when n is expressed in decimal form. When all the powers are multiplied and it is expressed in decimal form, that's how we define it as that's how we count number of digits in n, right? So now if you are interested in finding number of digits in n, how we can do that, guys? Okay, so the number of digits, there is a formula that we can deduce in finding number of digits in a big natural number n is c plus 1, where c is what we defined, that is a characteristic. M is between 0 to 1. M is not 0, but M is between 0 to 1 in this formula. Because when M is 0, directly we can find number of digits, because in that case then it would be in the form of when m is equal to 0, natural number n would be in the power of 10, and whatever there is there in the power of 10, that is would be the answer. So m is a positive fraction. So how we can get that, guys? Let's see. Let's see from some example, like let's take this only. If you the we need to take log. The first step is to take logarithm of n, and we have to check for the characteristic 1 greater than characteristic. 1 greater than characteristic is the number of digits in n. Okay, like let's take this number 2 to the power 10. Log 2 to the power 10, if I calculate, okay, it is the value of log 2 base 10 is given already. I also know the value, which is 0.301. So it is 3.01. So it is expressed as 3 plus 0.1. So C is what, guys? C is 3. So as you can see here, C is 3. So 1 greater than C is number of digit, which is 1024. So that's why. Okay. That way we can do this. So guys, let's take another example similar to that, where n is 2 to the power 30 and log 2, the values must be given. So log 2 is 0.301 is given. We have to find number of digits. So as usual, we'll take log, and using log m to the power n, which is n log m, 30 will come in multiplication of log 2. Log 2 substituting value into 30 gives 9.03, which is 9 plus 0.03. So number of digits is what? So C is 9, guys. This is C, 9. So answer is C plus 1, which is 10. Okay, guys. So it is 10 only, guys. C plus 1. number of digit is 10. We can take this simple example also, log 2. If n is 2, how many digits are there in 2? If n is 2, how many digits are in 2? So as you can see, the logarithm of 2 is 0.301. So c is 0 here, and number of digit we can say is directly we can say that number of digit is 1. Okay, so c plus 1 is 1. Okay, now another example we will take, guys, where now it is 3 to the power 27. So log 3 is given to be 0.477. Same question, number of digits. So proceeding with the same concept, taking, yes, log both sides. 27 will come in multiplication. Log 3 will substitute, and multiplication gives 12.879. So C is 12. Number of digits is 13. Now if it is n is 2, 5 to the power 200, log 2 is 0.301. How we can find number of digits? So guys, what should be the hint to this? Because 5 is there in terms, when you take log, 5 would come in log, like log n will give you log 5 to the power 200, and 200 into 5. Okay, so log 5 is not given, but log 2 is given. So how we can do this question, guys? So yes, if we think like how we can express log 5 in terms of log 2, so which reminds us of this, log 5 is what? Something minus log 2 is log 5, so this something should be what? So yes, it has to be log 10 base 10 minus log 2. So log m minus log n is log m by n 10 by 2, which is 5. So log 10 minus log 2 is 1 minus 0.301, 0.699. So log 5 is so log 5 is calculated as 0.699, that we will use here. 200 into log 5, 0.699, 200 is 139.8. So C is what, guys? 139. So number of digits are how many in this number? Yes, plus 1, which is 140. So guys, now let's take these two example. If now my question, there is different concept that we are doing. See, after this point, there is exactly how many zeros are there? 1 zeros are there in this example. In this example of 0.005, number of zeros are how many? 2 zeros are there before a significant digit arrives, like before 5 and after the decimal point. Here also after the decimal point, number of zeros are 1. Okay, here number of zeros after the decimal points are 2. Okay, so as you can see here, if the question is the same, number of zeros after decimal point are how many for a positive fraction n? If they are asking for a positive fraction, as you can see, this 0.08, 0.08 and 0.005, these are positive fractions only. So the question is how we can find number of zeros after decimal. So it is, guys, what? Minus of c plus 1, where log n is c plus n and c is defined as usual as the characteristic m is 0 to 1. But basically there is a shortcut, guys. Okay, the shortcut, before I explain you the shortcut, I will do it directly by the shortcut. As you can see here, number of zeros after decimal in this example is what? Here it is 2. Now the value of log 0.0505 is minus 2.301. So minus 2, directly if you multiply it by minus 1, you will get 2. Here also in this example, the value of log 0.08 is minus 1.096. So minus 1, if you directly multiply by minus 1, you will get the answer. Okay, so no need to separately go for expressing it in terms of characteristic in Mantissa. It is not required. Simply if the value of the logarithm, which comes out as like this, minus a point b c d, where a, b, c are some whole numbers, then what is the answer? What is the answer means what are the number of zeros after decimal for n? So directly if the value of log n is minus a point b c d, where they are a b c d are whole numbers, the answer is what, guys? As I said, using those two examples, it is a only. As I said, you have to just multiply it by minus 1, right? Here we multiplied by here we multiplied minus 2, so we got 2 by minus 1. Here also the value of minus 1 multiplying by minus 1, we got the value as 1. Okay, so no need to go for this formula, directly shortcut we can use. We will see few examples to illustrate my point. Again the question is same. We have to find number of zeros after decimal before the first significant digit arrives. Let's say n is given to be minus 3 to the power 50 and log 3 is given. Taking log, minus 50 comes down in multiplication. Minus 50 into the value is minus 23.85. So minus a point b c d, we will compare it to this, means a is what? See, b is 8, b is 8, c is 5, they are whole numbers. So a is what? A is 23, guys. A is 23. So answer is what? 23 only. Okay, answer is 23 only. Similarly, another example, minus 12 to the power 11. Okay, again we have to find number of zeros before first significant digit arrives. Taking log, power minus 1 in multiplication. Now log 12, it is understood that the value of log 2 and log 3 are given to us. So I haven't written in the question. So log 4, log 3, how it came? Well, log 12 is log 4 into 3. Log m plus log n is equal to log m plus log n we have used. Log 4 is log 2 square, which is 2 log 2 in the next step. 2 log 2. Log 3 as it is, log 2 value is substituted. Log 3 is substituted, log 2 is multiplied by 2. So this gives this plus this as 1.079 multiplying by minus 11. A bit of calculation, definitely there is minus 7.099. So this is again of the form minus a point b c d. So a is what, guys? 7. So that is the answer. A is 7. So 7 is the answer. Okay, guys. Let's solve this question, guys. 2 raised to the power 5 log base 4 root 2, 3 minus root 6 minus 6 times log base 8 root 15 minus root 10 is equal to what? Is equal to what? Basically, we need to simplify this and get an answer, most probably in terms of some rational number. Okay, free from log. So what should be the approach, the hint to this? So guys, as you can see in this question, here the base is 4 root 2, here the base is 8. So we can simplify these two bases to get a common base. So what should be the base? The common base. So as you can, if you think, you will and you can also take help of this 2. So this is also 2. One more thing, here 3 minus root 6, is there any irrational number that we can take common from here and here? Okay, and if we take something common from these two terms, So are we getting any common terms also? Okay, so we will work on two things. We can take something common from here, okay, and here, and we will make the base common, keeping in mind that here this is 2, okay. So that's a hint, and then we will simplify it, and most probably it will be reduced to this. So now you must have, it must be clear to you what should be the common base, right? And then we can use log m minus log n and this and so on. That way it can be done. So that's the strategy, that's a hint. So now moving on to the solution part, as I said, we will express it in terms of base 2. So 4 root 2 is expressed as 2 square and 2 to the power half. 8 is expressed as 2 cube. Root 15 minus root 10, root 5, root 3 minus root 2, root 5. So as you can see, root 5 is a common term here. And in the same way, 3 minus root 6 we have written as root 3 minus root 2, root 3. So you can notice root 3 is common here. So we can, okay. So what we will do in the next step, this 2 plus this becomes 2 to the power 2 plus half, the base I'm talking about. So which gives 2 2s are 4 plus 1, 5 by 2 in the next step, like this. This is the base. Okay, now we can take root 3 common, so it becomes root 3 minus root 2, and here it was root 5 common, so root 5 will take common, so root 3 minus root 2 will be left with. Okay, and now this 3 will go down using the fact log m n to the power a is 1 by a log m base n. So 1 by a, which is 3 in this case, okay, comes down in multiplication. So this is what has happened in this step. The next is this 5 by 2, again using the same law that I told you, using the same law. Here this 5 by 2 base will come here. Okay, so we are left with 2 here and 2 here. So as you can see now, the bases are common now, and 5 and 5 cancels out, and this 2 will go up in the multiplication. So it becomes like this, it will go up. So it is, this 2 is here now. Okay, now this second term is as it is. Now we will take 2 common from here and here, so which comes out like this. Rest of the terms are as it is, as in the previous step. So now as you can see, the bases are same, so we can use log m minus log is log m by n. So log m by n we have used. So root 3 minus root 2, as you can see, they are common, they get cancelled out. Now 2 is in multiplication, it will come in the power of root 3 by root 5. Okay, it will come in the power of root 3 by root 5 using n log m is equal to log m to the power n. So it becomes root 3 by root 5 square, okay, which is 3 by 5. Now using a log x base a, this 2 to the power log base 2 3 by 5 is 3 by 5, okay, which is the answer. Okay, so guys, let's try this sum. 1 plus log base 2x minus 4 whole upon log base root 2 root x plus 3 minus root x minus 3 is equal to 1. We have to find x. How we can approach this, guys? So what we can do, we can make base same. That's the approach, guys. Base same, and we will make the base same to be 2. Root 2 we can also make. not an issue. So here the base was root 2. I will write it 2 to the power half, and this half will go down using the law, and then this 2 will go up. So everything, the entire question would be in base 2, and we can solve using product rule. And okay, and whatever the values that we obtain, we have to check in the original equation. This is the approach. So the solution goes like this. As I said, we will write base as 2 to the power half, and using this law, okay, where the base power b to the power n goes in the denominator. So 2 to the power half also goes in the denominator. So we are left with 2 here. Now this half, and here 1 we have written as log 2 base 2, and log x minus 4 using the property log a plus log b, these two gets multiplied. This 2 goes up, and this 2 now will go in the power of that y. Yes, again using the log m log n is log n to the power m. So now both sides we have log, so we can cancel the log using this log a equals to log b. So we can cancel log both sides, and a gives a is equal to b. So we got a is equal to b. Now squaring, expanding a minus b whole square, and cancellation. Okay, these two, x 2x gets cancelled, minus 2 minus 8 cancels, gives 4, root squaring gives 16, and then x square, this gives finally 25. So x is 5 minus 5 possible. Now if you substitute minus 5 in the original equation, take this term, first term, second term in the numerator, it gives negative. So this is minus 5, we will discard, guys. This solution we will discard because it is making the argument negative. So now x equals to 5. Okay, x equals to 5. We can substitute, or we can directly write the answer, but just for verification, I am writing, substituting. When you write 5 minus 4 becomes 1. And similarly, 5 plus 3, root 8, root 2. Root 8 is 2 root 2 minus root 2. Log 1 is 0. So this becomes root 2. So this is 1. 1 equals to 1. So the answer is 5, guys. So that way it can be done. Let's see this question, guys, where x is an angle between 0 to pi by 2. And log 24 cos x base 24 sin x is 3 by 2. We have to find the value of cosec square x minus 8 tan square x. So guys, how we can proceed with this? What should be the hint of this question? So as you can see, nothing much is given, only one equation is given. Let's say C stands for cos, S stands for sin. So we will convert this into exponent form, and since you will see this would be the power. So in order to remove the power in the base, we have to do what? We have to square and solve to get the value of sine, cos, or cosec, or square, or tan, because if we can get one trigonometric value ratio, other ratio can be determined using the triangle. So proceeding with the solution, let's write C as C for cos, S for sine. This doesn't serve any purpose of any concept. Rather it is good, it will it will aid in writing less. So 24 cos, 24 sine, 3 by 2. 24 sine will push 3 by 2 up in the power. In order to remove this 2, we have to square both sides. So 24 becomes 24 square, cos becomes cos square, and this 2 and 2 gets cancelled. This 3 would be put in the power of 24. In the next step becomes 24 cube sine cube. Left hand is as it is. So as you can see here, 24 square, 24 cube cancels out. We are left with 24 only. Cos square we will write 1 minus sine square, sine cube as it is. Now we will take this term, these two terms on the right hand side, and we will, since this is a cubic equation, we will try to factorize in such a way that we get one factor. So we know that 24 is nearer to 27, which is cube of 3, and here also sine cube is given. So I will write 24 as 27 minus 3. So writing 24 as 27 minus 3 sine cube plus sine square minus 1 as it is. Now which two factors we will take as common? So yes guys, this and this we will take, and this and this we will take. So 27 s cube we will write as 3 s cube, because 27 is 3 cube. 3 cube s cube is 3 sine whole cube. Okay, so this is 3 sine whole cube minus 1 cube came from here. This one is written as 1 cube, and here we will take sine square common. So we are left with 1 minus 3 sine. So a cube minus b cube, guys, do you remember the formula? A minus b, which is 3s minus 1, a square plus b square. What is the next term, guys? So yes, plus ab, which is 3 sine into 1. Okay, here also we will take minus common. So this plus sine becomes minus sine square as it is. So 1 minus 3s becomes 3s minus 1 in the next step. So as you can see, we can take 3s minus 1 common like this. So we would be left with what? 3s whole square, which is 9s square, plus 1. 3s into 1 is plus 3s. So we are left with a quadratic and a linear. 3 sine minus 1, 0 will clearly give sine as 1 by 3. Any s value can we get from here? Quadratic. So we can check the discriminant of this quadratic, b square minus 4ac, where this is a, this is b, and this is c. So substituting the value of b, a, c, you will see this is minus 27, which is negative. So no real roots, so we won't get any s. So whatever s we got is 1 by 3 here. So what for other trigonometric ratios, what we need to do next, guys, because we need to find cosec square minus 8 tan square. So what we will do, guys, we will draw a triangle like this. Okay, so this question mark using Pythagoras theorem is what, guys? So guys, if you see, this has to be under root of 3 square minus 1 square, which is 8. 8 is 2 root 2. So sin x is 1 by 3. So obviously cosec square x would be 3 square minus 8 tan square x. Tan x would be perpendicular upon base 1 by 2 root 2. The square of 2 root 2 is obviously what? So it is 8 only. 8 cancels out. 9 minus 1 is 8. That is what, guys? That's the answer to this question.